is a quick video explanation to go with the rest of the homework problems. Starting on 18, we know we have a rectangle, and I went ahead and marked the given diagonals. They are bisected. Also, because it's a rectangle, I didn't show this, but we should also know opposite sides are congruent, so that would be 2 and 3 tick marks. I went ahead and labeled the given that we had. So they gave us that NQ was the 5x minus 3, and QM was 4x plus 6. And I see they have little tick marks, so that lets me know that they're congruent. And I got that by knowing that the diagonals bisect each other. So from here, we should know to do our 5x minus 3 equals the 4x plus 6. Okay, so we're going to go ahead and solve for x, which I know you can do. X is 9. But they want us to find NK. Okay, NK represents the whole diagonal. We have to plug it back in for our part. We should see that one part of the diagonal is 42. So the whole thing is 84. Okay. Now, on 19, because they're referring to NM, and that was the 8x minus 14 and JK, which is x squared plus 1. We have opposite sides are congruent, meaning that the JK is equal to NM. And we did this one today in class, part of your entrance tickets, and most of you were able to set up the equation using the correct property, the correct relationship, and you saw you had to factor. So you're going to do that again, so you can handle that. Make sure when we plug in, we're plugging in positive numbers, so we have positive values for our links. Now, here, there's 3 things you have to do. Find the best name, the list of property used to find the missing part, and then measure the missing angle. So the first one I believe we hit. If not, some classes got to it, some did not. But you should see that this is a rhombus because we have all sides congruent. And if it's a rhombus, then I'm given angle measurements, then I should use that the diagonals bisect opposite angles. So that's why we have the markings here to show that. And then if I know this is 59, then angle 1 is also 59. And angle 2, the diagonals are perpendicular, so angle 2 is 90, 3 is 90, and you should say that 4 is also 59. 10, hopefully you see it's the isosceles trapezoid, because we have 2 non-parallel sides that are congruent. Opposite angles are supplementary. So, and the base angles are congruent. So, right here, this is a base angle, this is a base angle, and we have base angles at the top. So, the ones that are opposite each other are congruent, so we know 1 is 67, and we should be able to get angle 2. And you got that. Here, we're going to name it. The best fit name, since we have this box right here, is a rectangle. 90 degrees. So it's for one, you show it for all. And if it's a rectangle, in a rectangle, the diagonals are congruent and they bisect each other. Opposite sides are congruent. Opposite angles are congruent. So when we have congruent diagonals, we create isosceles triangles in here to find our missing angle. So hopefully we're using diagonals congruent and bisect each other. So now that I know I have 106, you can use your vertical angle to help you find angle 3, and you can use your linear pair to help you find your missing angle. And we should be using our isosceles triangle here to help us find angle 1. So I can get, using this isosceles triangle, remember, I'm just going to redraw this. We have 76, or 106, excuse me. And so the base angles are going to be congruent. So angle 1 actually equals to 180 minus the 7, yeah, I think, minus 106 divided by 2. So basically we're taking our 74 divided 2. That gives us our angle 1. And then we have our angle 2 because 1 and 2 are complementary. So I think you can take care of that. So, and 4 and 106 are supplementary. And here for our last one, for naming best fit, finding the missing parts, we should have a kite here. It is a kite because we only have one pair of consecutive sides, okay, that are congruent. We have the top and the bottom. And when we have a kite, or I'm sorry, there's two pairs. I said one pair. When you have a kite, only you have exactly one pair of opposite angles that are congruent. So our opposite angles that are congruent are our angle 1 and 2. But it's a quadrilateral, so all quadrilaterals have a sum of 180. Our property that we're going to use is that fact that there's exactly one pair, excuse me, one pair opposite angles congruent. So 1 is equal to 2. The quadrilateral is 360. I think you can figure that out. We add, subtract, divide by 2. You got it. Alright, so here you need to draw and label pictures on a separate sheet of paper. It's not enough room for you to maybe to work these out, so you do need to draw them on a separate sheet of paper. I'm going to kind of make sure we're getting the problem started correctly. This first one is requiring us to retrace some algebra skills. We have a rectangle. The diagonals intersect at W, so I kind of drew a rectangle intersection. If it's a rectangle, the diagonals are congruent, and so they bisect each other. And I went ahead and labeled my VW was the 2x plus y, WS was 36, and RS was x minus y, and VT equals 9. So I went ahead and labeled that and color coded them. So I knew that WS is congruent to VT because these were opposite sides. Okay, and opposite sides are congruent for a rectangle. And I knew that VW is equal to WS because the diagonals bisect each other. So, sorry. So if that is true, the diagonals bisect each other, and I can just do some substitution. We should have x minus y is equal to 9, and 2x plus y is equal to 36. Hold on just a second. Okay, I fixed it. Sorry about that. So, 2x plus y equals 36. So now we have a system of equations. So I have a negative y and a positive y. So I can use addition to eliminate my y's. That would give me 3x is equal to 45. And I divide by 3, x is 15. So now that I have my x, I believe, oh, I want us to find x and y. So now that I have my x, I can just plug it in. 9. I think you can handle that. You got it. Take care of it. Gave you the simple one. Now, for number 2, I'm going to get you started. We have another system. So we're looking at VR and TS. Those are opposite sides congruent. So I know it's going to look kind of weird, but I'm just going to go ahead and write. We know that VR is going to equal to TS. And we're looking at VT and RS. So VT, those are opposite sides. And the RS are going to be congruent. So if we rewrite these, hopefully we have x is equal to, oh, not x, sorry, y. Because VR is y. Y is equal to x plus 11. And y minus 3x is equal to x plus 2. Now the difference here is we can change it so it's using elimination so that the x and the y is both on the left side. But I don't necessarily need to do that because the y here is already isolated. It's already by itself. I know what it's equal to. It's equal to this expression, x plus 11. So I can take that and substitute it for the y underneath. And I basically, when I rewrite it, x plus 11 minus 3x is equal to x plus 2. Now we're down to single variables. We can combine like terms and solve it, and then plug it in to find the other variable. So I kind of got you started. Hopefully that'll help you finish it. And then here we're going to do rectangles again. I went ahead and sketched the rectangle. I think I forgot to mention this because I had it already labeled, but when you label, we talked about in labeling a polygon, you go into consecutive order, whether it's clockwise or counterclockwise. So you can have your A in a different spot, but just make sure that if you're going clockwise, it's A, B, C, D, or if you're going counterclockwise, they're in order, okay? Now, they are identifying or labeling angles here. DAC is my red angle pointing to that intersection or that angle that it would exist right there, and CAB is here. But since I know, and I should have did that in green, since I know it's a rectangle, that's a right angle, then I can add them together, and they are complementary, so they equal to 90. Now for AC and DB, AC and DB, and I'm just gonna highlight those parts just in case. AC, DB, those are the diagonals, and the diagonals are congruent for a rectangle. Just sort of doing a side note, diagonals congruent. So x squared is going to equal to 6x minus 8. Again, this is a quadratic that I know you have mastered. All right, so when we move on to, oh, I went the wrong way, or did I? No, I didn't. Okay, so when we get here, we're now kind of putting it all together. And so I do want you to refer to the other problems that I did for you or kind of got you on the right track for. Again, make sure we start at our markings. For example, if I was looking at number 5, we're talking about AC, and we're talking about BD. I just did that. They're equal. Solve for X. 6 is just like the one I just did on the previous slide. Solve. I think you can handle this. I do want to talk about the last little section here because we're dealing with the rhombus. So I'm going to check here. I want us to draw a rhombus. My rectangles were not all that cute anyway, so I'm going to go ahead and use this little tool here to help me make my rhombus. And again, like what I was saying, make sure we label consecutively. So we have a P, Q, and we have R and S. It says with diagonals intersecting at T. So if it's a rhombus, our diagonals are intersecting at T. So SQ is one diagonal, PR is the other one. They intersect at T. When they intersect, because it's a rhombus, they are perpendicular. The shorts are bisected, the longs are bisected. And if it's a rhombus, all the sides are congruent. Now, there is another property we're going to show, and I'm going to show it with number 17. But on number 16, they're talking about ST and SQ. Well, ST is part of the whole diagonal that I know it's getting bisected. So I can just say, for number 16, if I double my ST, it equals SQ. Okay? And so, real simple, we have the value of SQ. Now, when we get to 17, because they're talking about if the measure of PRS is this angle right here, is 17 degrees, find the measure of QRS. Want the whole thing. So, well, when we have a rhombus, the diagonals bisect each other. The opposite diagonals. Diagonals bisect the opposite angles, sorry. So, right here, those two angles would be congruent, and they're being bisected, and are obtuse. Same thing. So, well, I already know that this is 17. That's my PRS, and they want us to know what QRS, that's the whole thing. So if I just double that 17, we have the value of QRS. Okay. Then they also want us to find on 18 STR. Well, that should be real simple because with the marking, diagonals are perpendicular. You got that. And then SP and PQ, also sides are congruent, we have that one as well. And I believe that is it. So hopefully this helps you finish your homework. There were two videos, and if you have any questions, come see me in the morning. Thanks. Have a good weekend.